Now that you can do simple summaries, in this section you will learn some techniques to dive deeper into summary visualizations. As a motivating example, let's quickly revisit one of the visualizations we just created. The distribution of total fare amount shows us that nearly all fares are under $100, but there are a few in the dataset that get up to over $1,000. We also see that the average fare is around $10, and some fares are close to zero. It would be interesting to dive deeper to see if other variables in our data can explain the variability in fare amount. We can often learn more from our data by introducing more variables into our summary computations to see if there are any interesting interactions that arise. In this section, you will learn a few techniques for doing this. When working with two or more continuous variables, you can bin pairs of variables in 2 dimensions and visualize the bin counts. To investigate the effect of other variables on summary statistic computations, you can group or facet these computations according to other variables and visualize how the summaries vary according to different values of these variables. You may have seen examples of grouping as well as faceting in other courses. A useful technique for visually investigating the relationship between 2 continuous variables, particularly when the data is large, is to count the number of observations that fall into a 2-dimensional hexagonal grid and plot the result. This can be done using ggplot2's geomhex function, which does the binning computation for you prior to plotting. The granularity of the binning can be controlled by the bins argument. To investigate the relationship between the total fare and the tip amount, we can make the following plot. Here we also add a reference line along which the fare matches the tip amount. It's surprising that there are many observations along this line where the fare is basically the same value as the tip. We see a clear high count linear pattern in blue, indicating a standard percentage tip, but we also see a lot of variability around that pattern, and many fares with low tips that don't fit the linear pattern. Faceting allows us to look at data in more detail or in new ways by breaking the data into pieces and applying the same visualization to each subset of the data. This is easiest to do when the faceting variable is categorical. Adding faceting to an existing visualization, such as the plot of number of taxi rides versus time, is as easy as adding facet wrap to the plot specification and specifying the variable you would like to facet on. In this example, we facet on the day of the week, which allows us to easily observe the evident strong day-of-week effect on ridership. Note that you can facet on multiple variables with facet wrap, and another function, facet grid, can be useful when faceting on 2 variables. Note that with faceting, any plotting element you add to the plot is applied to all of the facets independently, as in this example, where we add geomsmooth to highlight the differing progression of ridership over the year on different days using a robust linear model. Ridership is increasing over the course of the year on the weekends, while it remains more constant midweek. Let's now use these